All right, so Unit 2, Day 8b, we're just going to continue on with a few more examples. There's really not anything new on here from A. It's just going to be more examples and maybe more difficult examples than what we did in the first part of this day, Day 8. So first off, we're going to solve these equations or inequalities. We're going to use some sign change tables. We also may just use a calculator because some of these are just kind of crazy to use the sign change table with. But so first off, this first guy here, it's a rational, which means we're going to look for what makes the top equal 0 and what makes the bottom equal 0. So I think it'd be easiest to factor this first. If we get the factors for this guy, it makes it a whole lot easier to see what makes the top 0, what makes the bottom 0. So on the top here, I've got, let's see, that'd be what, plus 4 and minus 3. And on bottom, it's going to be minus 2, actually just squared times itself. So when I make my table here, it looks like my zeros, let's see, zeros in my undefined. My zeros are going to be negative 4 and positive 3, and then it's going to be undefined at 2. So I need to go from, I'll say here's negative 4. The biggest number I got over here would be 3. So these are where the zeros are. But also at 2, I've got an undefined. So those are like the critical points. Those are where special things are happening. And now I'm going to try to check between all of those. So I'll just say if I plugged in, I'm going to plug in negative 5. I'm going to plug in 0 because negative 5 is on this side. 0 is in between here. Let's say 2.5, and then let's see, so 4 would be a good one to go. So those ones I picked. As long as you pick numbers in these intervals, you'll get the same answers I get. But maybe pause the video and try these out. Try to get the signs right, okay? So try to get these signs right. Remember, these are all quotients, and you have 4 things to worry about here. You could actually just do the bottom. It's going to be squared, so you could think, the bottom would have to always be positive if this is going to be an x minus 2 squared. No matter what you plug in, you're going to subtract 2 and then square, so you're always going to get a positive. So I can just do this right now. I can put a plus on all the bottoms because the bottom can't be negative after I square that binomial by itself. Okay, so go ahead and pause the video, try those out. Hopefully, let's see, we got negative times negative, so it'd be a positive over a positive. That's going to be a positive. Here I've got a negative over a positive, which is negative. A negative over a positive, which is negative. And then a positive over a positive is positive. So I've got positive, negative, negative, positive. Okay. So the question was, when is this function greater than 0? So it's over here and it's over here. So from negative infinity up to negative 4. Not including negative 4 because it's not equal to, or from 3 off to infinity. Okay, we'll jump down number 2. If you remember right, we do not want to use that sign chart unless it's one fraction on this side. So I do want to add these together to get one fraction on that left side. So the least common multiple on this guy, when I go to add them, my least common denominator is going to be x plus 1 times x minus 3. If I multiply that denominator by this one, the x minus 1s would cancel out and have an x minus 3 times 1 on top, plus, and then over here, this already has an x minus 3, but it needs an x plus 1. So it'd be x plus 1 times 1. Let's see, now if I do some simplifying before so this would be, let's see, x, so it'd be 2x minus 2 over x plus 1 times x minus 3. If you want to write this as 2 times x minus 1, that's fine. It's really not super important. As long as you can get the sign at the top, it's fine. If you think it makes it easier. So what makes the top equal 0? So if I set that top equal to 0, so I'll just say zeros. If I brought the 2 over and divided by 2, see, that'd be a positive 1, so that'd be 1, right? Yeah, so 1, and then the undefined would be at negative 1 and positive 3. So these are my critical values. When x is 1, negative 1, and 3, something's happening. So I'll draw my line here. I need to go from -1 and then to 1 to 3. So at 1, that's a 0, but at the other ones, it's an undefined. Which means the undefineds are probably going to be asymptotes. Yeah, nothing shared, so those are going to be asymptotes. So something weird's going on with those asymptotes there. Now let's pick some numbers for the interval. So I'd say -2, because that'd be over here. Now between here, 0 is a good one. Plug 0 in. And between here, I'll pick 2. And then from there on, I'll just pick 4. Okay, so again, I want you to try to pause the video, see if you can do it on your own. If you feel really good about it, finish it. If you're struggling, maybe just do one at a time. Do one, hit play, and look at that answer. But try these out on your own. Okay, so I got a negative over a positive is negative. Got a negative over a negative, which would be positive. A positive over a negative is negative, and then positives. So let's see here. So it'd be negative, positive, negative, positive. And it's asking, when is the function greater than or equal to 0? So now we're going to do some equal to's on this one. So it is, let's see here. At -1, it's nothing because it's undefined, so we don't want to include that. But it is positive all the way up to and including 1 because it's 0 and that's equal to. So that's going to be an including. And then now 3 is undefined, so we can't include 3. So that's going to be a parenthesis, but on up to infinity then. Okay, going to the bottom here. Let's see here. So again, same thing. This is an equal to, so we're not going to do the sign chart. We're just going to solve this like on the backside of yesterday's. Was it the backside of yesterday's? Actually, it might have been. Yeah, from day 7. We did this in day 7. I'm sorry, this is more of a day 7 review problem. So anyway, I want all of them to have the same denominator. Write down this is over 1. I'm going to choose to do the multiply everything by the least common multiple of the denominator, which would be r squared minus 2r. You could also say r times r minus 2. Either one would work on this one. So that first one's going to, if I multiply by this whole fraction by that, I'd have r plus 5 minus, this one has nothing, so I'm going to multiply by that, and it didn't get canceled, so it would be r squared minus 2r equals, and then here that would cancel, so it would just be a 1. R plus 5 minus r squared plus 2r, because I got to distribute that negative out. Line these up, I got negative r squared plus 3r plus 5 equals 1. And, wait a second. Yeah, then I bring that 1 over. Yeah, bring this, so subtract the 1 over. So negative r squared plus 3r plus 4 equals 0. Now some of you might say, well, I bring everything to the right side to make that a positive r squared. That's fine too. We'll get the same answer in the end. Because I'm going to factor out a negative. So I want that to be a positive r squared for my factoring. Okay, so multiply, get -4, add to get -3, so -4, positive 1. So r equals 4 and -1. And I would want to check, you'd want to plug this in and make sure that they don't make any of these denominators 0, because then it's an extraneous circumstance or an extraneous solution. So if I plug these in here, if I plug in 4, so it'd be 4 squared is 16 minus 2 times 4 is 8, so that's a positive number, or it's a real number. Plug in -1, -1 squared is 1, and then plus 2 would be 3, so that's fine. So yeah, these are both fine. These are both working out. Number 3, how did I skip around here? 1, 2, 3, 4, 5. I'm sorry about the numbering here. But this guy here, what's the least common multiple? So let's factor this first, see what factors it has. And this looks like -2 minus 5. So I'll just multiply everything by that. That's the least common multiple. The first one already has r minus 2, so it's going to be 1 times r minus 5, which is just r minus 5, plus this has both of them, so they cancel out and you just have a 1. And then r minus 2, so it'd be 6 times r minus 5. On the right side, it's be r minus 4 equals 6r minus 30. Let's get the r's together, get the constants together. So I've got 5r equals 26 divided by 5. So 25 or 26 fifths. If I plug that in, that's not going to make either one of these equal 0. It's not going to make any of those denominators equal 0, so that one's good. That one works. Let's see. The Dixie Packaging Company, they're making one of those boxes that we talked about. It's been a few days ago. I can't even find what day it was. But we did a few days ago. We did this where you have this rectangular, let's see, a 20 by 25. So this is 25. I'm going to cut corners out and fold along these dotted lines, fold those sides up and make a box out of it. So that means, you know, for volume is length times width times height. Well, in this case, the volume has to be at least 600. So here's my 600. Has to be at least, and my length, width, and height, I need to write them all in terms of one variable. And I'm going to use the variable, the x that I'm cutting out. So the length now would be 25 minus 2x. The width would be 20 minus 2x. So I'm cutting an x and x, so it would be 20 minus x, what's left? And then the height would be x. And now this, let's see, it'd be really nice if this equaled 0, because then I could easily find my critical points here, but this is the factored form, but this is greater than or equal to 600, and it needs to equal 0. Like over here, these were all greater than or equal to 0, so these were the critical points. The factored form helped me see that. I can't just say that, let's see, 25 halves is a critical point, because that makes this equal 0. Well, I want to know what makes this equal 600. So I'm going to have to use my calculator. I'm going to multiply all this together. And if you want to try that, you know, we could foil, you're going to FOIL this out, and then distribute an x to all of that, then bring the 600 over. Okay, so when I get done doing all of that, I've got 0. On the other side, I had 4x cubed minus 90x squared plus 500x minus the 600 on the end. Okay, and that has to be greater than or equal to 0. I'm going to use my calculator then to find out when is this positive. Okay, so I got it in my calculator. I put all that in there. Again, just pretend like it's equal to 0, and then I can graph it. It's going to be hard to see anything here. So let's go zoom whenever it's done graphing. I guess I can see it here. So, and I know that it is a positive cubic, so it should make an N shape. So now, did it come up, come down, and then back up? Or did it come up, down, and back up? That's what I need to figure out here. So let's go to zoom. And see if I can get this to fit into one screen. So it looks like it did come up, come back down, and it should come up again somewhere over here. So I'm going to check, I'm going to play with my window for a little bit here. I know I don't need anything less than, I don't need to show anything less than 0. It's definitely negative when it's less, or when x is negative. So I'm going to play with my screen here a little bit. So after fiddling around a little bit, I see I need a minimum x of 0 and a maximum of 20. I changed my y scale just so it's a little bit easier to see here. But when I graph that, it looks something like this. So I need to find when is my volume greater than 0. And then I have to figure out, is this even feasible? Because remember with this, there's a feasible domain here. So I think if the small side is 20, that means that the most I could possibly cut out would be less than 10. If I cut out 10, I got 10 this way and 10 that way, there is no square left to fold up. So if I'm looking here on 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of this stuff where it's positive is not even feasible for this problem. So I'm going to throw that part out. I just need to figure out what's this interval right here. So use your 0 functions here. So let's see, that's going to be between 1 and 2. I'm just going to type in 1 and 2. So it looks like 1.659. It is an equal to, so that one gets included. And it's going to be up to this other one. So second calc, 0. Again, that's, let's see, 2, 3, 4, 5, 6. It's between 6 and 7. So left bound 6, right bound 7. So 6.159. That would be included. I'm rounding about 3 decimal places. If Math Excel asks you, just round to the appropriate number of decimals. Okay, now this guy, hopefully a little bit easier. It's a little bit more straightforward. That was kind of a crazy problem we needed a calculator for. So now, again, I need to factor this guy. And you think cubics are hard to factor, but this one, if they all have an x in them, so take an x out first off. Oops, greater than or equal to 0. And because I'm trying to see where are those critical points, what makes this guy equal 0. -2 plus 1. So it looks like there's zeros at 0, at 2, and at -1. So here's -1, here's 0, here's 2. And the value is 0 at all those. So I'm just going to pick points between there. Let's pick -2. Here I'll pick -1/2. In between there I'll just pick 1, and then I'll pick 3. Okay, just to have some, again, just plugging these guys in. You can maybe pause it and try it yourself. So you got negative, negative, negative equals a negative. Negative, negative, positive is a positive. Positive, negative, positive would be a negative, and then all positives make a positive. So when is this greater than or equal to 0? Well, from -1 to 0, again, these are included because it's an equal to, and they are zeros. And then from 2 to infinity, sorry, 2 is included also, off to infinity.